Have you ever stood in your garden or just looked at a park and wondered, why is that one plant doing great while the one right next to it looks like it's on its last legs? It's a puzzle, right? Well, today we're going to solve it by digging into a secret hidden right under our feet.
It is so frustrating, isn't it? You give them the same sun, the same water. You think you're doing everything right, but you get completely different results. The thing is, the answer isn't something you can see on the surface. It's a clue that's buried in the soil itself.
That's right. The entire story of a plant's life, whether it flourishes or fails, it's all being written in a silent language, a chemical conversation that's happening constantly in the soil. The ground is literally the stage where this drama plays out.
So let's learn how to read it. We are going to decode this secret language, and I promise by the end of this, you'll understand the one master key that unlocks pretty much everything about the world beneath our feet.
And that master key? It's something called soil pH. Now, don't let the sciencey terms scare you off. Think of it like this. pH is the soil's operating system. It's this one single variable that sets all the rules for everything else. What nutrients are available, what microbes can live there, everything. If you get the pH right, the whole ecosystem just clicks into place. So, to get a handle on this master variable, we use something called the pH scale. On the surface, it looks like a simple number line, but believe me, it tells an incredible story about the secret life of soil.
Okay, so here it is. The scale runs from 0, which is super acidic, all the way up to 14, which is very alkaline. Right there in the middle, at 7, that's neutral. Think pure water. Anything below 7 is acidic, like lemon juice or vinegar. Anything above 7 is alkaline, like baking soda. Most of the soil on our planet is going to fall somewhere between 3 and 10 on this scale.
So what's actually going on with the chemistry here? Well, it's really just a tug of war between two different ions. In acidic soils, you've got a ton of these free-floating hydrogen ions. And in alkaline soils, the hydroxide ions are winning the battle. That simple balance right there dictates the entire personality of the soil.
Now here's the part that is absolutely mind-blowing about this scale. It's logarithmic. What that means is that a small change in the number is actually a massive leap in reality. So a soil with a pH of 5 isn't just a little more acidic than a soil with a pH of 6, it's 10 times more acidic. And a pH of 4, that's 100 times more acidic than 6. Tiny little shifts on this scale mean huge, huge consequences in the real world.
Okay, so we get what pH is. It's a number on a scale, but why should you or I actually care? Well, because it's that master variable. It controls the entire web of life in the soil, and that in turn affects everything from our backyards to the world's food supply.
Think of soil pH as the ultimate gatekeeper. It decides which nutrients get unlocked for plants to use. It's the bouncer that controls which microbes get into the party. It even changes how the soil is physically put together. It literally dictates the health and vitality of the entire underground world.
This chart shows what I mean perfectly. It's the Goldilocks effect. See, in really acidic soil, major nutrients like phosphorus are locked up, but other things like iron can become so available they're literally toxic. Then you go over to the alkaline side, and that same iron becomes unavailable and plants get sick from deficiency. For most plants, that sweet spot, that just right zone, is a pH somewhere between 6.5 and 7. Now you might be thinking, great, I'll just change my soil's pH. Well, not so fast. Soils have this amazing natural defense called buffering capacity. It's basically the soil's immune system against pH changes. Soils that are full of clay and organic matter have a really strong buffer, and they fight hard against any change. Sandy soils, though, they have a weak buffer, so their pH can swing around much more easily.
All right, so let's take a closer look at the two ends of the spectrum, acidic soils and alkaline soils. Each one comes with its own very specific set of problems for anything trying to grow there.
So, in really acidic soils, once that pH number drops below 5, a new villain joins the party: soluble aluminum. This stuff is just plain toxic. It gets unlocked from the soil minerals, and it just attacks plant roots, stopping them from growing and blocking them from taking up water and nutrients. It's a real killer.
And on the flip side, the alkaline side, the bad guys are usually salts and sodium. Just look at this table. You've got saline soils, which are loaded with salts. This makes it incredibly hard for plants to drink water. It's like being stranded at sea and trying to drink salt water. Then you have sodic soils, which are high in sodium. Sodium is not only toxic, but it just wrecks the soil's structure, turning it into this dense, hard-packed mess that roots can't break through.
Okay, we've gone through all the problems, and it might sound a little bleak. But here's the good news. This is fixable. You absolutely can take control.
With the right know-how, you can manage your soil's pH and build a healthy, thriving environment.
And the strategy? It's actually beautifully simple. If your soil is too acidic, your goal is to raise the pH. To do that, you add liming materials. If your soil is too alkaline, you need to lower the pH, so you use acidifying materials. That's really it.
So to raise the pH in acidic soil, the absolute first step is to test it. You cannot fix what you don't measure. No guessing. Once you have your number, you can pick your lime, and then, this is so important, you have to calculate how much you need based on that buffering capacity we talked about. A heavy clay soil is going to need way more lime than a light sandy one to get the same result. Then you just mix it in really well.
Now lowering the pH of alkaline soil. This one's a game of patience. You can slowly add acidic organic matter or use specific fertilizers. For a more direct hit, you can use elemental sulfur. But the main takeaway here is that it's a slow process. This is a marathon, not a sprint. You have to be patient.
You know, as we wrap this up, it's worth remembering a really simple truth. Healthy soil truly is the foundation of all healthy life on this planet. Understanding its chemistry isn't just for scientists. It's a vital step for all of us to become better guardians of our little patch of the earth.
So, the next time you see a struggling plant, don't just see a problem, see a message. Remember that the soil has a story it's trying to tell, and now that you know its language, you can finally listen. The only question is, what is your soil trying to tell you?